Hello once again, folks. Welcome to Thinking Out Loud from Async KPI. My name is Fran Mendez, and today we're going to be talking with Dominik Obermaier from HiveMQ. And we're going to be discussing about a really cool topic that actually makes me think a lot, which is like, what could be we doing or what could brokers be doing more in order to achieve this data consistency and this documentation of everything, every topic, every message, and so on, right? And how we could be integrating better with brokers, like Async API with brokers, or even cloud events with brokers. Like, how could brokers be integrating better with existing specifications, right? So for those, before we start, for those of you who don't know, so this is an Async API live stream. So we adhere to the Async API code of conduct that you can find on our GitHub organization. Also, we'd love to share that. Here it is. So I'm gonna put it there for a while. So if you need closed captions, please head over to YouTube and enable them there. You will be, it will be possible. I hope we didn't mess up with like last time, and they're working. Also, and I want to make it clear, this is not an interview format. So this is a chat, like I like to call it like a casual chat or a thinking session if you want. So so don't be shy. Just join the conversation on the chat if you want. Be be part of this live stream, even if you're not on camera. That's totally fine, right? So yeah. As we do with Async API, we try to make everything as community driven as possible, and this is no exception, right? So please join the conversation. Don't be shy about it. And yeah, so yeah, I'm not gonna be like talking more about it. With no more delay, I'm gonna introduce our guest today. So, hey, Dominik.
Hi, Fran.
Welcome.
How's it going?
Hey, look, how much time? Like it's been a long time we don't speak. Like what, like 5 minutes? Not kidding. So hey, everything's going well. I hope so I don't know. So Dominik was telling me on private chat if the sound is good. Your sound is good. I hope my sound is as well. I'm on Chrome. I hope you are as well. We
Yes,
stream
yes.
well on Firefox, and I use Firefox for as my daily browser. So yeah, so that's why I was telling you before to use Chrome or Brave as well, right? So
I'm not yet brave enough for Brave, so I'm using.
I kind of tried for some time, but then I don't know. I switched it back to Firefox. Don't know why. And yeah, so Dominik, maybe you want to tell us a bit more about yourself, like introduce yourself for those who don't know you.
Oh yeah, absolutely. Hi folks, my name is Dominik Obermaier. So I'm CTO and co-founder of a company called HiveMQ. We're basically the company is providing, let's say, software for the Internet of Things. So many people will probably know the HiveMQ MQT platform, which we also have an open source version available. And yeah, basically, I'm a messaging guy. So I've been doing communication protocols for quite some time. So I think for more than 10 years now, I almost exclusively deal with MQTT and other, let's say, communication systems in the IoT space. So I also worked on a book about the foundations of the Internet of Things. And yeah, so in general, I'm this kind of IoT guy, but really more on the service and non-communication side. So I helped with the specification of MQTT version 3, as well as version 5, which is the 2018 version of MQTT. And yeah, and also I'm currently working on protocols like MQTT SN, which is MQTT for sensor networks, as well as higher level protocols, basically sitting on top of MQTT like Sparkplug and others. And this is something I'm really interested in. And so I'm super excited to have this conversation today about async API because while, of course, I think messaging is really great for a lot of use cases, when it comes to tooling compared to traditional request response protocols like HTTP, I still feel we aren't quite there yet, and there's a lot to improve. And this is why I'm so excited about async API really driving that forward and pushing the envelope here. So yeah, excited to have this conversation.
Nice. So that was a great introduction. I love it. So maybe so for those who don't know as well, like so Hive, I don't know folks who are watching us or who will watch us in the future on the recording. If you're learning or if you learn in the past, or if you're gonna learn about MQTT, like I did in the past, most probably you'll end up reading HiveMQ resources in the internet. At least for me, it was like super useful resources to learn MQTT, like all these tutorials on how to basically use MQTT, and that was super helpful. So yeah, congratulations to whoever wrote that. I don't know if it was you or your company.
So yeah, so we have some multiple series. For example, we started the blog I think 2013 or so with the so-called MQTT Essential series, which was really basically me trying to basically make the MQTT specification more digestible. This was Christian Götz, who's our CEO at the company, and me. So because we felt that this was even it's a very simple specification, that folks found it not as accessible for learning. While a specification is really great if you want to implement that, to get an overview, and especially for software architects, these people are usually pretty busy, and so we figured, hey, why don't we bring it in a bite-sized version? But also for ourselves. I mean, while I do love writing specifications, my brain is really not designed as a hard drive, apparently. So this is why I usually write also stuff for myself, so I can find it easily, because Google is my default information finding thing. And so yeah, and so this grew. But I mean, the more recent series like the MQTT version 5, fundamentals, and so on, we have awesome colleagues writing that. And also when it comes to the higher level protocols, so we have some awesome people there who are really good at what to do, and they provide this kind of content for the community. Because I mean, in the end, when it comes to open protocols, and this is a fundamental belief I have, by the way, is I so believe in open protocols, because literally the reason why we can talk now is based on open protocols, and the whole internet is based on that. Also with this onion layer, or this I call it the onion layer. Some people are calling it, let's say, the OSI layer, basically. So and this is so great that we have TCP, which is open. We have also other protocols on top, which we can use, and also on the application side. And MQTT, for example, is no difference. I mean, it relies on things like TLS, which we also use for HTTP, and yeah, but usually when it comes to messaging protocols, historically, a lot of the, especially very old messaging protocols, are more on the proprietary side, and they're very, I mean, obviously, many folks will know that. We also had this kind of weird thing in the past where we specified on APIs, for example, with JMS, but the implementation itself, the VIA protocol, was completely proprietary. So you don't really get the interoperability. You just basically get, let's say, you can program against the same API, but in the end, you still have this kind of vendor login. And this is something I'm really glad that we left that beyond us. And now the industry is focusing on open protocols like MQTT for IoT devices or AMQP, which is really great for the backend system. And also protocols which are technically open, like the Kafka protocol and so on for messaging. I think this is really great that now
It's
the
really
industry
great. Yeah.
in the last 10 years, 15 years came to the conclusion, hey, it's awesome if we get interoperability between systems.
It's awesome that we get more and more open protocols, and they're not closed source. Um, I would argue though that it's like, please stop creating protocols, because then we have to support them in async API.
Yeah,
Just
and
kidding.
this is something. I mean, this is what I really like. But I think from a scope perspective, async API is a harder not to crack than, for example, Open API, which is like focusing on HTTP. And from a scope, I feel it's a bit more narrow. But with like messaging systems are so different, because like AMQP is completely different from MQTT, while on the surface it looks pretty similar. The problems, and I hope we can talk about this, are so much different. So I'm wondering, so do you also feel that with async API, the scope is really, let's say, much broader and sometimes probably a bit harder than with Open API?
I do feel it. I literally feel it. Like I felt the pain, and like the headache in the past, trying to come up with an async API specification that was like let's say outlining what every protocol, or at least every protocol that I knew at the time, had in common. And that was a headache, because you couldn't go like really too deep into each protocol feature, because yeah, like you said, like AMQP for instance is so different to Kafka or to MQTT. Then how do you, for instance, with Kafka, you have, I just came to my mind, like Kafka has a concept of a key and a value, right? That doesn't exist in AMQP, for instance, right, or in MQTT. So how do you map that? If we add a key and value on async API, then how do you map that to MQTT and AMQP? Even more, what if the concept of a topic doesn't exist, like in the case of WebSockets?
Yeah.
Right. So that is like, right. So we kept it as simpler as possible, like keeping. I mean, not simpler is not the word here. So we try to keep it as common as possible. Like only having in the core spec you have only the common stuff between protocols, and then we incorporated this feature, which is protocol bindings, where you can define specific protocol specific information, right? And that is like kind of extension. Like you're using MQTT, cool. Here's your MQTT protocol binding. There you can define all the MQTT specifics, right? So yeah. And I was listening to you before when you were saying like when you were working on this essential guides, right? The essentials, and you were saying like you sometimes write for you because your brain doesn't function as a hard drive, and I was like completely relating. So shameless confession here, I keep looking at async API documentation every day. And I sometimes, because I don't remember how to do some things in async API, and and even what's more funny to me is that sometimes it's like, who wrote this shit? Like,
Oh yeah,
and then you go on GitHub and it's like history or blame, and it's like, oh, it was me, of course.
Yeah.
So yeah,
This is I like this the same thing as with any code. I mean, Git blame is the most brutal feature Git has, because like in 90% of cases oneself is to blame.
yes.
So yeah.
So yeah, I completely relate on that. So so the topic today for the audience, I'll remind it again. Like so I wanted to invite Dominik to talk about how we could better integrate brokers, or how do we imagine we could integrate brokers, not just HiveMQ, right? So like brokers in general,
Yeah.
with async API, or due to the last interactions on Twitter yesterday,
Mhm.
also not just async API, but specifications like cloud events, like which I completely forgot in the initial topic definition. But like I mean that like how could we make sure, like how do you imagine that we can, or do you imagine this is possible and it's viable, that from a broker perspective we end up having some such kind of features, like for
Mhm.
instance validating the message payload or the headers, validating
Mhm.
against a network API definition or a cloud events definition or something like that.
Yeah. Yeah. Oh yeah, absolutely. I mean, I think I think there are basically I think it's three levels to talk about on the when it comes to async API. And so for people who are not as familiar with MQT, I'd like to give a quick background, so it's hopefully easier to understand what I'm trying to say. So MQTT is when you look at large deployments, and here at HiveMQ we have like very large deployments. Like we have a typical, just for people who are not familiar with the scale.
Mhm.
So a typical MQTT deployment we do with our company when it comes to cloud deployments is usually 1 million devices and above, and we're talking about concurrently connected devices who
Mhm.
are basically sending stuff all the time. And so somewhere between 1 million and 10 million is, let's say, on the higher end, but usually having a deployment has more than 10,000 devices connected. This is usually where it gets interesting in the cloud. But also, and this might also be interesting for that conversation, is that MQTT brokers are not only residing in the cloud. Very often you have this kind of tiered architectures where you have an MQTT broker sit, for example, inside a factory, or multiple. But let's, for the sake of conversation, make it simple. You have one broker in a factory, and you have 10 factories, for example, and then have one big cloud deployment, for example. So you have to, and then on each of these brokers, you have multiple devices be connected. So get off this kind of tiered architecture, this almost federated architecture with
Mhm.
MQTT brokers also, which I think makes it a bit more interesting also when it comes to the async API conversation. So I think a key thing with MQTT that is quite different to traditional messaging system, or let's do it with Kafka. Kafka is something we see at the use with MQTT and Kafka all the time. They're
Mhm.
complementary because they're solving very different problem in a very elegant way, and they really blend together very nicely. So you probably MQTT for cases where you would use Kafka, and you definitely shouldn't use Kafka where you would use MQTT.
No.
And and I mean, Kafka is like from in a whiteboard, Kafka would be usually a big pipe. You don't have a lot of topics usually. I mean, so what we have, like for 10 to 100 maximum for most deployments, some of them do have more, but usually you scale over the partitions and you don't have a lot of, let's say, topics. Usually there are other use cases, but I mean, we know customers who have like 2 topics basically. In Kafka, a lot of
Mhm.
partitions, support a lot of throughput, but they don't have a lot of topics. While others might have hundreds of topics, but I haven't seen a Kafka deployment with more than whatever 5,000 topics. They might exist, but I've not seen them so often.
Yeah. I've been working on one of them, like at New Relic,
Oh,
when I was working at the New Relic.
uh-huh.
So the Kafka broker had, like, I will say, I can't remember the amount, but I will say like easily above 1,000 topics.
Oh,
Like,
wow. Okay, wow.
but to be honest, it's because it was used for two different purposes.
Uh-huh.
One is to ingest data from the agents. So New Relic is for monitoring, right?
Yeah, yeah,
So when you so the agents are installed in your server or in your machines
yeah,
are constantly sending data to New Relic. So
yeah,
this data
yeah.
ingestion is done through Kafka,
Mhm.
and so that was the main purpose. It's
Mhm.
because of the high throughput of Kafka. That's why they
Yeah,
chose this
yeah,
technology.
yeah.
But then it's like, oh, since we have the broker here, let's just also do our microservices architecture,
Mhm.
event-driven architectures, um, on top of Kafka as well. And
Oh,
what happens is that it people start creating topics for their microservices,
yeah,
but since it's not documented anywhere,
yeah.
right? What the topic is doing, I mean, not anywhere, but it's not clear. Um, then whenever they have to make a breaking change on the messages that are being sent on the topic,
Yeah.
since they don't know who's consuming this message,
Mhm.
they don't touch it. They keep publishing this message, and they start publishing the new version on a different topic, and
Oh, I
then
see.
on a third topic, and then on a fourth topic, and
Must be
so
really fun to be site reliability engineer for that.
there's a huge, actually, and they're really good, and I think they're actually now improving that
Yeah,
this setup, so
yeah,
that's really cool.
yeah,
But yeah, like the thing is that you end up with a lot of topics because of this, because you're using
yeah,
probably, and I mean, I don't want to sound like an idiot here, but probably it's because like people are using um, Kafka in this case for something that is not meant for. Like in the
mhm,
case of, for instance, like communicating microservices, like
mhm,
like as a PubSub,
mhm.
broker, like for that you have many AMQP brokers or even
Yeah,
MQTT brokers, which are
yeah,
good enough. But Kafka has these stream capabilities, which
yeah,
I'm not sure if, I mean, it can be used. It certainly can be used. We did it, and we have
yeah,
Sergio on the chat, who
yeah,
was also working with me at New Relic, and and he
yeah,
was saying like, yes, there was a lot of topics. So
yeah.
yeah, so
So,
so yeah,
so
like
yeah,
probably it's
but I
because
think,
we're using technology. Sorry, go ahead.
yeah, but I think you're completely right. But I think that the point I try to make is, so even if you have thousands of topics, or let's say 10,000 of topics, let's even say, for sake of conversation, you have 100,000 Kafka topics. I mean,
Mhm.
this would be very huge. Like this would be a
Yeah,
lot. So
yeah.
this might be orders of magnitude more than people have. When you think about an MQTT deployment, you literally have usually at least one topic per device, at least, if not more. So I give you one example. One deployment of but this is on the larger side of things. We have a deployment of a single MQTT Hive cluster, which has more than 160 million subscriptions, growing every day. And this is like really a lot. MQTT
Mhm.
topic subscriptions, which in the end are, I mean, individual topics. And this is like, even if you have 100,000 topics, like I'm saying more than 100 million, this is like a lot of additional zeros. And this is like completely mind blowing, because if you think about MQTT has so many devices, this means you have this kind of a lot of very small data streams from each device to a
Hmm.
single MQTT broker in the cloud. A lot of very small streams. When you think about Kafka, you usually have this very thick pipe where you
Mhm.
basically pipe in data. And what is often done at the MQTT level and the MQTT broker level. So, for example, we have a native Kafka integration in our broker for doing exactly that. You can take all of these very small streams and basically pump it into a big Kafka stream or multiple Kafka topics. And this also bidirectionally. So very often you also get this kind of Kafka topics where MQT broker consumes and then figures out how to distribute it across probably millions of devices. So this is like very different. And so you have a lot of topics, a lot of, let's say, data streams on the MQT side. And on the Kafka side, it's usually orders of magnitude less, usually. And so this is, I think, where it really blends together very nicely. And this is also, I think, an interesting point where we can basically, from an async API standpoint, where, yeah, a lot of interesting conversation can happen. Also, what async API can provide here.
Mhm.
On the MQT level, but also on the Kafka level, because, and I think you mentioned that earlier, if I understood it correctly, the MQT broker has one advantage. It is the central entry point and the bidirectional conversation point with all the devices out there. and be it cars, be it whatever, washing machines, or just mobile apps. And so you can do a lot of interesting. So you could do a lot of interesting things here, from, let's say, validation, like is the top, like policies in the end. Basically, async API specifications could serve as a policy. Like what is the device allowed to do? So this is the specification. Even what kind of data is the device allowed to send, and so on. I think an interesting conversation would be how this would be structured if you have, let's say, 100 million topics, how you would get it manageable with async API. And this might be, I think, the part of the conversation where I frankly need to learn. I'm not an expert on a topic, but this might be, I think, an interesting challenge to solve.
So, yeah, not easily. So how do you do it? Not easily, for sure. Like, because what you say, like, you have in multiple occasions, you have brokers deployed on the edge. So, like in a factory, for instance. So they're like close to the machine that is actually emitting or receiving events. So yeah, like this is like the edge, right? So how do you? I'm curious about. Before I answer this question, I think I need to know something. Like, is the topic creation needed beforehand? Like before a publisher can publish on a certain topic on an MQTT broker. I know that this can be automatic. Like you publish, this can be dynamic. The publisher publishes in a topic, and then it's created behind the scenes, right? But is it usually the case, like topic creation is dynamic, or you have to provision the topic before?
This is, so I would say it's dynamic, but within a certain rule set. So, for example, let's to make it more plastic, I'm just looking out of the window and I see a lot of cars here. So let's do a car example. So one could imagine to have a topic tree, and for the people who are not familiar with MQTT, you have this kind of hierarchical topics with like a POSIX file system, right? So you get this nice tree basically. And just for sake of conversation, let's say the topic would be car / the identifier of the car / GPS data, really just for sake of conversation. And this would be the topic, like GPS data for the car would be published. And this is a pattern you see a lot with the MQTT. So you usually have this kind of identifier of the device itself also in the topic. So while you get a decoupling, of course, on the backend, you can then still figure out like for what car is this GPS data. So you can address that. And the same is also true for subscribing. Let's just say the car is subscribing to cars / my ID / commands, for example, to receive commands from the cloud. So just with that pattern, you would have for each car deployed and manufactured, basically, you would create 2 topics, one for a subscription and one to publish to. And so this is what I mean. It will be dynamic because with each car basically connected to the infrastructure, there will be these 2 topics basically created. But like only this specific car will probably use it and should use that. And what you usually do on the MQTT broker, you provide rules and say, okay, only car with identifier France car would basically should also be allowed to subscribe and publish to like the France car identifier, like cars France car GPS, for example. And this is what you would usually do. So this kind of variable interpolation, if you will.
So let me then frame it in another way. So, for instance, when you we're in a factory and we're publishing to a broker that is sitting in that same factory, and this you said like it's federated because you have 10 factories, and it's probably federated between the 10 factories and probably with one on the cloud as well. So they're all like kind of federated, right? So there is a federation mechanism happening there, which is like communicating. This broker is communicating not just that the message has been published, but that a topic has been created, right? Like there's a new topic here in this broker. So I want to notify the rest of the brokers that this topic is already it's brought into life. It's like that. You know what I mean? So it's like so the rest of the brokers are aware that this topic now exists. Is this something that happens behind the scenes?
Yeah, you usually not that much. So I think from a and this is I think a key difference with MQTT towards, let's say, other technologies, that topics are a thing, like a like a for example, like a traditional RabbitMQ installation. I mean, a topic has a configuration usually, and yeah, reserves some kind of memory and stuff. And with MQTT, a topic is actually just a metadata of
the message.
of the message.
Yeah.
So while the broker, of course, needs to be aware of that, and I mean, this is pretty complex and complicated how a broker would basically even do that scale. This is not easy to do. This is actually pretty hard to do in a distributed system, but in the end, it's still completely dynamic, and the broker usually will not make any assumptions on that. And while, I mean, you can restrict that, of course. This is something like our customers do, because you really want, especially if you know beforehand, like, how does it look like? A factory is pretty static. It's not that like there are 10 machines each day that come online by accident. Because if a new machine is deployed somewhere, usually people know. And this is not an overnight thing. This is a huge thing. If a new car is manufactured, like, this is not something you want an administrative action to be happening, right?
Yeah.
And so these are, I think, different use cases. So I would argue for the factory use case, you would actually want a kind of static, let's say, enforcement of that. And then, of course, I could imagine that you also want to notify other participants and brokers about that happening. I haven't seen that yet, but this is an interesting case to think about.
Yeah, I was asking because, like, I was trying to think, like, maybe we can take advantage of this federation mechanism where this information sharing happens between different brokers, and so if we deploy, if we configure one broker with async API, we just imagine we don't know yet how to do it, but it's like the broker supports, I don't know, configuring, uploading some async API files and or some async API document or whatever to configure it. Then this could be federated across all the brokers, taking advantage of the existing mechanism, right? So it only happens whenever there is a change in the configuration, right? So it's not on every message, otherwise it will be too much, right? And that the way I was thinking is like, maybe you say, for instance, you have a cloud broker and you're interacting with your cloud broker, and you want to you configure it with async API or with cloud events or whatever, and then you spread this information across all the nodes, all the other brokers in the factories and everywhere, right? So then these brokers become aware of the topics that they might that they can expect, the messages they can expect in these topics, or if that makes sense from an MQTT point of view. But like what the headers, like what kind of data they can expect there. Like policy enforcement, I can understand, might not be a big deal here. I may be wrong, but I don't know how often you hear about situations where people publish wrong messages, like with the wrong shape or something, and then something breaks. But something that I will be really interested is about, for instance, having visibility, like how many topics we have in the platform, who's publishing what, who is subscribed to this topic, who is receiving this information, how they are communicating to each other, because they're not communicating directly. So the only way to know how they're communicating to each other, because in the end a message flows from one point or multiple points to multiple points. So you want to know these connections, right? So that you can govern, like, or even monitor what's happening in your
basically create a map of what's happening, if you will. So to discover that. This is actually an interesting point. I also think a lot about that, because there are, especially just look at people who have, for example, you basically have a smart home deployment with MQTT. So a lot of people are using Mosquito there or having a community edition for their smart homes. And so with a lot of people I have conversation with, while they start with one device, bringing that online, a second device with MQTT and so on. And sometimes people are wondering, like, what's actually happening? What kind of topics are subscribed to? What's actually happening? And this is in a small case, like with probably 10 devices, 20 devices, people are still getting confused what's actually happening. And
imagine a factory, right? Or in multiple factories.
Yeah, and honestly, you would be surprised when we also help people basically discover what's happening in their deployments. People are very often surprised by some applications which nobody knows about, who are like legend application, but the platform team was not informed that then now is a new application. Policies or the permissions were too let's say too broadly configured in the beginning. And then so this stuff happens like in real life. And so yes, this would absolutely help. I'm wondering though, as from an, and this might be, I don't have experience with that, so it would be interesting in your perspective. From a scale perspective, so my understanding is async API usually is done with one file. This is at least how I use it, right? So can you basically split it up? Because I'm worried about what do you do if you have whatever 1 million topics or so? If a single file wouldn't be, let's say, overkill, is there any mechanism in OpenAPI to basically segregate configuration or anything like that?
There are, but they're not perfect yet. They're not perfect, but they're not even good, I will say. So you will still need to have like a single file with all the million topics. Just that each topic will be defined on another file. So, but you still will need this single file with the 1 million list, right? Just it will be just a list of topics and reference to external files.
Okay.
But you still need that file, like an index file, right? But with version 3, we're trying to make that better, right? So the reusability a little bit better. And actually, something that we are we're not yet proposing, because actually after this live stream we have a spec 3.0 discussion because we're working on the next version of the spec. And something that we're working on is how can we make it like how can we make the spec in a way that where you can actually maybe not like you said, like you have 1 million topics. Say for instance you want to have like groups of this 1 million. Inside this 1 million you want to have domains, right? Like some people call it domains, or can be domain as in domain driven design, or can be domain as in something you invent yourself that is suitable for you, right? So a group, let's say a group of topics. So that will actually, it is something that we still have to figure out how to do it, but it is something that we want to do. To my experience, I think the way it's going to happen is not inside async API. So probably we'll have to create like a top level new specification where you can group all of them, and they will reference existing async API files or something like that. So so yeah, that's we're still yet to figure out, but it's possible. So
this is interesting. So because we worked on a similar problem. And because we developed, or we basically opened to the public a tool called HiveMQ Swarm a while ago. And so since we always had the problem that the scale we are testing and quality assuring our product against is very hard to achieve, because like we are literally having 10 millions of devices, like hundreds of thousands of messages per second flowing through multiple data centers around the world and stuff. And MQTT has the interesting property that it has an open and standing TCP connection. And having 10 million standing TCP connections really brings every infrastructure, especially looking at Azure, to its limits, actually. So, and this is why we developed a tool also, like a distributed load test tool, and basically scenario tool where you plug in a scenario, what we call scenario, and then then under the hood, it basically will do that, similar to what you do with JMeter, like in a click. This basically generally creates the load and the behavior and can publish to millions of topics and so on. And here we also had this kind of grouping concept where we grouped MQT clients, where we group topics and so on, and also basically work also with rules, where we basically embed rules, how messages are created and how are they subscribed to. So there's a kind of rule engine in there, which works pretty well. Actually, it gets complicated for complex scenarios after some time, but yeah, and you can of course expand that if you want, but usually you get, like in the scenario which I could just mention, like there's a car and then slash the identifier. This would be literally like this line of code instead of probably millions. So this is something like in a follow-up conversation or so. This might be interesting. So because we tried some things which were not great, but now we found something that is at least good enough, and perhaps this might also be interesting for async API.
Oh yeah. But please share this, like even during the call if you want, or after the call. So this just reminded me of a case. So we have some folks from Sora Robotics. Let me just make sure that I'm doing this. I'm reading this correctly. But this, damn YouTube, I don't want to watch ads now. So they they gave a talk at the Async API conference, and they're a robotics company, and they're using Async API, and they had this exactly the same problem, which is they had like a huge deployment with many topics, and therefore having a single Async API file was like too much, right? So they created a tool where they could split into multiple Async API files, and then they had a tool that it will assemble all of them together, right? So they were working on separate Async API files, but at the end of the day, they will assemble them together. And there is the recording. Yes, so let me share this on the chat so people can also watch it. So there's this talk, right? And I completely recommend you watching this, since it's IoT related. They created some cool tools to use Async API with MQTT and with this IoT let's say application, if you want, and also solving this problem. I knew this was a problem for them. Usually we don't have that problem. Like people doing microservices architecture, they, like you said, like they have lots of topics, but not that lots of topic, right? So it's not usually, right? Or they just don't document everything, which is also it's also very probable. Let me also.
You spoke a secret truth. Now every enterprise architect on earth is embarrassed.
And we're here to remind you that you should document your services and your topics. We're gonna create the Async API police. No, kidding. That I mean, I understand that some people don't want to document everything. Like sometimes, if inside the same team, if you have 3 services talking to each other through the broker, but it's just to coordinate something between the 2 or 3 services, and it's not meant to be consumed by external other teams or something like that. Then I understand. It's like I don't care. It's like I know the code. My team knows the code. They know how it works. We don't need to document everything, right? I disagree, but by my experience, but I understand. So and I disagree because at some point you leave the company, you live there, and the problem remains there. And so
So speaking of that, there's one thing now I also have you in this call. I wanted to learn about it just for a long time actually, but never had the chance. So perhaps you can help me here. So this is true for many messaging systems, right? So while there is a specification, let's do MQT as an example here. There's a specification with version 3 and version 5, for example, with different feature sets. but also, I mean, while with MQT version 3, there is really no optional feature, like a MQT broker must support everything. Still,
Mhm.
some things have limitations. For example, AWS IoT as well as Azure IoT Hub, they have basically just support a subset of the features. For example, when it comes to retail messages or the topic structure and so on, there might be limitations on the side. So does Async API also have this kind of, let's say, distribution thing where you can also indicate, for example, okay, this is, for example, like a full-fledged MQT broker that supports everything. This is whatever the IoT Hub profile, which like has this kind of certain limitations. So because when it comes to validation and so on, because now if an architect would basically write their file against that and say, okay, I want to use a free topic structure with IoT Hub, for
Mhm.
example, this might be a problem because you're not allowed to do that. You need to follow their specific structure and so on. So
Mhm.
is there any way for applications to indicate that you have, let's say, a endpoint with limitations? Or so in terms of validation, or would this be like with free flow metadata, or how would one usually
You
address that?
you mean an async KPI if that's
Yes.
something that you can do?
Yeah, yes. So basically, because if you, for example, generate code, for example,
Mhm.
then you, I mean, it would be very bad if you would generate the code against basically a system that is not supporting the code generated, right?
Mhm.
And I would think if you because I think the value of async, one of the values is that you have the single source of truth, like in this file,
Mhm.
which you can generate code from, and where like you document things, and this should really reflect the reality.
Mhm.
And so is there anything like that planned or possible, like the limitations in kind of a metadata or so, or give applications a chance to understand, okay, this is IoT Hub, so my code generation should not use all that standard features supported by other platforms, for example.
Uh, no, we don't have this kind of like division, if you want, like this must be supported if, or this should not be supported if it's IoT case or something like that. Like the way we do, we have optional features that that
Mhm.
tooling might or might not support.
Mhm.
Um, that's the only thing that we have. Then for the rest, if you say I support async KPIs, this tool is supporting async KPI,
Mhm.
then you should be supporting all the
Mhm.
required features. Let's say, right? You have, like I said, you have optionals, but they're not a lot. Most of them are like required, and I think you actually brought an interesting point, because for certain use cases you might not need to have a fully fledged async KPI
Mhm.
support, right? Like for instance, yeah, there are cases where correlation ID,
Mhm.
you don't care so much about the correlation ID on the message.
Mhm.
Usually, I'm looking at you, WebSockets, but but yeah, it's always WebSockets. Maybe we should create an async KPI, a reduced version of async KPI just for WebSockets.
That's the
But
problem with the pure transport protocol, right? So
yeah,
yeah.
but yeah, like we don't have that kind of thing, but we can have it. Like it's just a matter of making a proposal. Like we're like
Mhm.
really community driven, and we listen to. It's not that we listen, because we, I mean, when I say we, it's really the community,
Yeah.
and the TSC is I think we're 30 something people already,
Oh
and
wow.
from different companies and backgrounds. So they um but on the spec, we're so far with three code owners still, and we're looking to augment that. So
Uh-huh.
we still, but then in any case, these are code owners. That doesn't mean that we have to do all the work. And actually, we don't want to do all the work. We want the community to
Yeah.
influence the future, like with version 3, right?
Mhm.
So yeah, like this is definitely open to happen. That we have like we look through the spec and say like, hey, from an IoT perspective, for instance, I don't care about this, and I don't care about this, and I don't care about this,
Mhm.
and when it's IoT and generating code, it should work like this. When it's IoT and generating documentation, it should work like this other way.
Yeah.
Uh, could work. I mean, might alleviate a little bit of the load on the tooling developers, right? On the product developers as well,
Mhm.
because because yeah, like supporting the full async API specification might be a little bit of a pain, right?
Yeah.
So yeah, I actually see the value there.
Mhm. So, I'm really curious also about code generation. So I think we haven't covered that yet. So because I think this is like super interesting, also for us, the kind of, let's say, code generation on the client side. Because if you now really either define beforehand or even would have the possibility to create a, let's say, an async API specification, basically on the broker side, and then it might be really useful to also generate the clients based on that
Mhm.
for an MQT perspective. And so since we also have an Apache 2 licensed library we developed with BMW a while ago, which is a high performance Java library for MQTT, which supports MQTT version 3.5 and all features and also optional features. This might be like the perfect fit also. And we were thinking also about like, how would this be a fit of, let's say, code generation? Because I think this is
Mhm.
interesting. What I personally don't understand, and I mean, this is I think a philosophical question. I know from the days back then when I did a lot of, let's say, database stuff with the ORM, the object relationship layer.
Mhm.
Um, like, are you writing the database first, or are you writing your, let's say, in Java, entities first, which generate the database? So the egg versus hen problem. And
Yeah.
what was it with async APIs? Do you see people basically writing their code first and then basically writing the async API specification, or people usually creating this async API spec and then generate the code out of that? So how's it usually going?
I see the two, and I don't see one like predominant above another. So
Uh-huh.
we have that's we call it like code first or design first, right?
Uh-huh.
So what do you do? Like, you design your APIs or your event-driven architectures first,
Mhm.
and then you generate the code, or do you code first and then you generate this API file from your code, from
Yeah.
annotations or something like that, right?
Yeah.
We see both. We see both, and actually. Um, uh, I have a blog post on the pipeline right now that I'm going to
Oh, nice.
publish in the next week about this,
Uh-huh.
and that it doesn't have to be either way, like, or either design first or code first. I think about it like, what if, like, our proposal with Glee, we have a framework called Glee,
Mhm.
which is, it's not, the concept is not new. The concept is the same as in GraphQL, for instance. The way GraphQL uses the schema
Mhm.
file to actually create the API. So if you want to create a new query, a mutation on GraphQL, or in gRPC, if you want to add a new message or something like that, you have to add it first to protobuf in the case of
Mhm.
gRPC, or you have to add it first um, to the GraphQL schema file, right? So because the code itself, it's using the specification, the schema file, as a
Mhm.
config file, right? So
Mm.
if it's not there, if it's not in the schema file, it doesn't work.
Mm.
Basically, it's like, it's not even like, you cannot make it work without putting it on the schema file. So what we're developing since almost a year now is a framework that takes an SNKPI file as a config file, right? And then you only work on the business logic, right? And
Mm.
if you want to subscribe to a new topic or publish to a new topic or something like that, the only thing you have to do is to put it on a SNKPI file, right?
Mm.
And then and of course adding the business logic behind it, right?
Yeah.
Like, when I receive this message, what do I do with it, right? So that's what you will have
Mhm.
to do yourself, of
Mm.
course. We're not yet with wizards,
Yeah.
but
Yeah.
the concept is this. The concept is like, what if it's something that you have to do at the same time? Like, meanwhile you're writing your code,
Mhm.
you have to be writing your spec, right?
Mhm.
Because if you don't do it like this, it will not work. Like, say for instance, if you don't have a subscribe verb on your async API file,
Mhm.
then it will not subscribe uh, to the broker, and you're not going to receive the message.
Mhm.
And so you will have to put it there if you want to subscribe, right? um, but that's like a limited use case, not use case, like, that's limited solution because it's only for people who don't have any code yet,
Yeah.
um, and can start with TypeScript or with Glee, right? Doing this, so cool. They're
Hmm.
covered. But those who
Yeah.
already have a huge code base, like they have hundreds or thousands of projects already
Yeah.
with code, with Java, for instance.
Hmm.
Um, how do you enforce that at code level, right?
Yeah.
So one thing that we're going to propose is adding, for at least for the major protocols, major frameworks, sorry, um, plugins for these frameworks that you
All right.
can, where you can actually enforce. The plugin will force you to have an SCP file that matches what the code is doing, right?
Hmm.
Um, not easy solution, but possible nonetheless. So yeah, that's what we see, and that's what we're advocating for lately. So yeah.
Mm. And this is, as I said, I mean, this is what I find so interesting about messaging, and even after like doing nothing else than messaging basically in more than 10 years now, it's really exclusively working on MQT. It's still so interesting because of the decoupling of stuff in messaging makes it so interesting as such an interesting problem to solve. And but yeah, as I said, it's complex, a bit more complex than if
Mhm.
you have a very tight relationship between a client and a server.
Yeah, actually, one of the biggest benefits of event-driven architectures is also one of the biggest drawbacks, which is like this decoupling nature, right?
Yeah,
It's like, this is really cool. You can just plug or unplug stuff, and yeah, you don't need to change anything else. Just plug a new service,
yeah,
subscribing to this topic, and just doing something with the message or
yeah,
publishing or whatever, right?
yeah,
Um, and it's really a pluggable architecture. It's really easy, right?
yeah,
But yeah, that is an advantage, and it's also a drawback because as soon as it grows exponentially, right,
yeah.
and it can go quickly out of hands, you
Yes.
don't know what's happening. Like you
Yeah,
don't know which messages are being published. You don't know who's subscribing to what. Um, then you cannot answer the question. This question that I often hear is like, I often ask, which is, do you know if you change this message, you make a breaking changes in this message that is being published, do you know who's going to get affected? Or are you blindly going to change it? Um,
yes. This
so
talk is the whole topic of retrofitting stuff, which I don't think we should open that can of worms right now. But this is also something that is very often needed, and this is also like what we see a lot. Like basically having also the MQTT broker um, help translate between versions because of incompatibilities in the field. Because usually it's much harder to update everything in the field than just have this kind of retrofitting stuff. Similar to what you mentioned with Kafka, what people with Kafka like just
yes,
publishing on new topics. The same is true for MQTT. So this is something like we see a lot of people are doing on the broker, but yeah, as I said, it can get out of hand extremely quickly.
yeah, yeah. So that is why that is one of the. So after all, like when I invited you to have this chat about like how can we make brokers to be more aware of what's whole and the whole thing and the whole architecture, if you want, the whole
Mhm.
um it was all coming from this situation. Like people are like, we want to have that control, right?
Yes.
um but if you're starting a fresh new project, that's not a problem. You have Glee, you can use Glee, and that will make you that will make you happy. That's
Yeah.
actually the claim. Like you'll be covered, like everything will be documented because you have no other option. But if you already have a huge code base,
Mhm.
we cannot ask people, I don't know, like say imagine at IBM or something like that, having,
Yeah.
or at BMW probably, or Adidas, for instance, who already have lots of deployed code, to simply migrate to Glee all their services, right? It's that will be insane. Like it's no, no, we're not gonna do it. But who has this power? Who has the power to do it like really easily? and I think it's the broker, right? So the broker is in the middle. So if you were able to, maybe not, so we could be validating messages as we were saying, but validating doesn't mean that you will stop messages, invalid messages, right? You can let
Yeah.
them pass.
Yeah.
Um,
Right. But there
but
multiple
just trigger
strategies you can do.
alarms or something like that. Just trigger
Yeah.
some kind of notification, or paging someone or something like that, right? Or yeah, something just for you to discover that something is wrong,
Yeah.
right?
Yeah.
Maybe the
Right.
schema definition is wrong or the message is wrong, whatever is correct, right?
Mhm.
So that will be actually super cool in terms of governance of the whole
Yes.
event-driven architecture,
Yes.
because that will give you visibility. You will be able to draw this map. People will be able to search for certain information. Something that happened, I mentioned New Relic before. So
Mhm.
I wanted to subscribe to specific user actions. Let's say, for instance, when a user signs up, I want to receive this message
Yeah.
with the user information, right? Like email, display name, and so on.
Yeah.
But I didn't know who was publishing this kind of message, and it was already being published. And I could just ping someone who has this information from the database, like
Mm.
it was a microservice architecture. So whichever team that had access to the user information on the database
Mhm.
could be triggering these events for me, right? I could ask that, but I didn't want to do that. I didn't want to do that this way. Like instead, started investigating, and I discovered that this same message, like a user was signing up, was triggered in three different points, in three different topics. So almost the same information, because people were not aware that this message was already being triggered in this topic,
Yeah.
so they couldn't discover it. So they were asking to create a new one, a new topic for them to consume the data, right? So,
Mm.
um, so effectively, is that you're creating a new topic per consumer, right? Which is like
Yeah.
it's a waste of resources, and yeah, and it's because of the lack of visibility. So
Yeah.
that is something that people could be just going into the broker platform or website or something like that, and search like user email, something like that, and here's a list of
Mhm.
topics where the user email is in the data payload, it's in the message payload or in the message headers. Might not be the
Yeah.
case, but yeah,
Absolutely.
something like that, right?
And
And
and and I think you're spot on with your observation and the things there, because I mean these are exactly the things like we think a lot about. We also work on specific things to make what you just said more reality. I personally do believe that async API might play a key role here. I think there is. I mean, the time is like there's so much we could talk about the topic. This is just amazing. So this would be something I would love to follow up at some point of time to really discuss also that in detail, because like and especially now with the async API 3, let's say, I'm baking and come up at some point of time, I do think there might be a few tweaks that would make it even more possible for this kind of very large scale, let's say, scenarios. And yeah, and this is something like I would be super interesting in having that conversation, how it could look like, or
yeah,
even how having you could help make that a reality.
yeah, I'll make sure I ping you about it. We were
Okay.
also interested because we want to for the next version. We're not in a rush, so we don't
Mhm.
know yet when we are releasing version 3.
Mhm.
But this time, we don't want to make a version of async API based on assumptions.
Yeah.
So we want to make it like we want to make an async API version that solves real problems,
Yeah.
right? So we want to work with the companies, especially with brokers, or and not just brokers, but companies having huge event-driven architectures deployments, right? Like so, and understanding what are their pain points, right? So yeah, and see what we can do there. If we can do something, of course, maybe we can't,
Sure. Sure.
but so yeah. So time is running over. Actually, we're 1 hour past already. So um, in case you want to say something before we leave, or
Not really. So just thank you for it. I really like the format. It's really great, and time really flies here. I do hope
yeah,
also people found it interesting. So for people who are not familiar with MQT and still made it to the end of the of this episode, you can find more about, if you're interested in MQTT and also a lot of things I said, you should just Google it or havingq.com and you find a lot of stuff here. But I personally, as I said, I just use Google all the time, also for the old stuff I write or people write here. So yeah, and also people feel free to reach out to me on Twitter or LinkedIn or wherever you can find me on the internet. I usually monitor these channels, and I'm happy to start conversations. I really love the messaging space, the IoT space, and also now that when it comes to specifications and so on, also async API is of high interest. So if people have any input, please reach out. I'm super curious about all the thoughts from the community.
Well, thanks a lot. I hope I spelled your Twitter account correctly.
Yes.
So thanks a lot for joining today. Really enjoyed that. Once we can do this in a physical place together at some point, we're gonna do this over a cup of coffee, maybe, or something like that in a sofa.
Love to.
That will be much better. But in the meantime, we'll have to stay in the office or at home or something like that and doing it remote, which is also super cool because we don't have to travel that much. So
Great.
Yeah. Cool, Dominik. Thanks a lot for joining, and thanks everyone for joining the live stream. I hope we didn't bore everyone at least, and yeah, see you in the next episode.
Thank you,
Bye-bye.
folks. See ya. Bye.
Yeah.